Welcome back, stargazer, to the sleepy cosmos, where we wander through the universe at the gentle pace of dreams. I'm so grateful you've chosen to spend this quiet time with me tonight. This evening, we're embarking on a journey to the hearts of stars themselves, those brilliant spheres of light that have captivated humanity since we first looked upward. They're far more than glittering decorations scattered across the darkness. Some of these cosmic giants could contain our entire solar system within their blazing atmospheres. Others have collapsed into objects so dense that a single spoonful would weigh as much as a mountain. And remarkably, every single one of them serves as a cosmic forge, creating the very elements that form your body, this planet, and everything you've ever touched. It's rather extraordinary when you think about it. The light reaching your eyes at this very moment may have begun its journey centuries, millennia, or even millions of years ago. Some of those distant suns might have already faded into darkness, their luminous whispers the only testament to what once blazed. Meanwhile, others will continue illuminating the cosmos long after our own world has become a memory. If you find peace in these gentle explorations through space and time, I'd be deeply grateful if you'd consider leaving a like or subscribing to this small corner of the internet. Your support helps other dreamers find their way here, one peaceful soul at a time. Perhaps leave a comment telling me where you're listening from tonight, a quiet apartment in Tokyo as the city sleeps, or maybe a cozy room in Montreal while snow falls softly outside. But truly, you don't need to do anything at all right now. There's nowhere else you need to be, nothing urgent requiring your attention. Just settle a little deeper into whatever comfortable space you've found. Allow your breathing to slow down naturally, becoming softer and more rhythmic. Let any thoughts or worries drift away, like clouds passing across a starlit sky. You don't need to remember a single thing from tonight's journey. In fact, it's perfectly wonderful if you drift off midway through, carried gently into sleep by the rhythm of these words. That's exactly what this is for. Now, get comfortable. Close your eyes if you'd like. Take one slow, deep breath, and as you release it, let yourself simply be here, suspended in this moment, ready to float among the stars. Let's begin. The cosmic giants that dwarf our imagination. The most enormous stars known to astronomy would completely engulf Earth's entire orbit around the Sun. Consider Scuti, a red hypergiant whose radius extends more than 1,700 times beyond that of our own Sun. If you could somehow transport this stellar behemoth to the center of our solar system, its outer layers would reach beyond Jupiter's path. Even slightly smaller supergiant stars like Betelgeuse or VY Canis Majoris would easily swallow Earth's orbit whole, leaving our planet vaporized deep within their glowing atmospheres. These colossal suns are relatively uncommon in the cosmic landscape. They burn through their nuclear fuel with reckless abandon, living brief but spectacular lives of just a few million years, a mere eye blink compared to the billions of years enjoyed by more modest stars. Their swollen outer atmospheres are constantly unstable, continuously shedding material outward into space in enormous clouds that drift away like cosmic smoke signals. The sheer magnitude of these giants serves as a humbling reminder. Our Sun, though immense by any everyday measure, large enough to contain more than 1 million Earths, is actually quite modest when compared to these true titans scattered throughout the galaxy. They exist at the extreme edge of what's physically possible for a star, pushing against the very limits of how much matter gravity can hold together before other forces tear it apart. Stars that outshine galaxies. While most stars radiate with familiar, steady brilliance, certain exceptional titans called luminous blue variables and hypergiants can pour out more energy than the combined light of billions of ordinary suns. Eta Carinae, one of the most famous luminous blue variables in our galaxy, releases such extraordinary amounts of energy that at its peak, it rivals the brightness of entire small galaxies. During the 19th century, Eta Carinae erupted so violently that it temporarily became the second brightest star visible in Earth's night sky. despite lying more than 7,000 light-years distant. Stars of this extraordinary type live dangerously close to the edge of stability, consuming their hydrogen reserves at absolutely staggering rates and frequently ending their brief lives in cataclysmic supernova explosions. The immense radiation pressure from these stellar powerhouses pushes outward with such force that it literally blows away their outer layers in powerful stellar winds, creating gorgeous glowing nebulae that surround them like cosmic cocoons. These brilliant beacons remind us that even a single star, for a short but glorious time, can dominate and illuminate the space around it for hundreds of light years in every direction. The ghostly remnants of stellar catastrophes. When massive stars conclude their lives in supernova explosions, their cores may collapse into something truly extraordinary: neutron stars. These bizarre objects measure only about 20 kilometers across, roughly the size of a small city, yet somehow contain more mass than our entire sun. The catastrophic collapse compresses atoms so incredibly tightly that protons and electrons are forced to merge together into neutrons, creating matter denser than anything else known in the universe, except black holes themselves. Their surfaces are unimaginably solid, their gravitational pull immense beyond comprehension, and their magnetic fields stronger than anything we can create or easily imagine. Despite their diminutive size, these stellar remnants shine across the cosmos, either by emitting powerful beams of radiation or by heating their surroundings with the leftover energy from their violent birth. Neutron stars are essentially the ghosts of once great suns, the collapsed cores of massive stars now transformed into spinning, incredibly dense remnants that challenge our fundamental understanding of matter and physics. They demonstrate the astonishing extremes to which the universe can push the laws of nature, creating conditions so alien that they seem to belong more to science fiction than reality. Pulsars. The universe's most precise cosmic lighthouses among neutron stars, some display even more astonishing behavior. These special objects, known as pulsars, rotate at absolutely staggering speeds, often hundreds of times every single second. With each rotation, they sweep concentrated beams of radio waves or visible light across space, creating a regular pulse pattern as observed from Earth, much like a cosmic lighthouse sweeping its beam across a dark ocean. The fastest pulsars, appropriately called millisecond pulsars, can complete more than 700 rotations every second faster than the blades of a kitchen blender at full speed. These pulses arrive with such remarkable precision that astronomers employ them as cosmic clocks, timing them with accuracy that sometimes exceeds our best atomic clocks here on Earth. The discovery of pulsars in the late 1960s initially raised fascinating speculation that they might actually be signals from advanced extraterrestrial civilizations, before their true nature as rapidly spinning neutron stars was finally revealed. Today, scientists use pulsars to test Einstein's predictions about relativity and even to search for gravitational waves rippling through the fabric of space-time itself. They rank among the most reliable natural timepieces in the entire cosmos, their steady beats echoing across the galaxy. Magnetars, where magnetic fields tear reality apart. Magnetars represent an exotic variety of neutron star defined primarily by their magnetic fields, the strongest magnetic fields known anywhere in the universe. A typical magnetar possesses a magnetic field up to 1,000 trillion times more powerful than Earth's protective magnetic bubble. Such incomprehensible power is difficult to grasp in any meaningful way. These fields would be strong enough to distort the very structure of atoms themselves, literally tearing apart molecules and fundamentally rearranging matter at the atomic level. When their tremendously powerful magnetic fields suddenly shift or realign, magnetars can unleash giant flares, releasing more energy in a tiny fraction of a second than our sun emits over hundreds of thousands of years. These incredible bursts have been detected from across vast cosmic distances, sometimes briefly outshining every single star in our entire galaxy combined, making magnetars temporarily the brightest objects in the Milky Way. Fortunately for us and all life on Earth, magnetars are extremely rare and none exist anywhere near our solar system. They serve as natural laboratories in space, extreme environments where scientists can observe what happens when physics gets pushed far beyond any limits we could possibly recreate on Earth. These stellar remnants show us just how strange and powerful the universe can become. Stars distorted by their own furious rotation. Not all stars maintain perfect spherical shapes. When a star rotates extremely rapidly, the centrifugal force generated by that rotation causes its equator to bulge dramatically outward, flattening the star into what's called an oblate shape, essentially squashing it into a cosmic pancake. One particularly famous example is Achernar, a bright star that spins so incredibly quickly that its diameter measured at the equator is 50% larger than the measurement from pole to pole. Such extraordinarily rapid spinning can actually fling material off the star's surface and into surrounding space, forming disks of gas and stellar matter around the equator. These dramatically distorted suns challenge our traditional mental image of stars as perfectly round, balanced spheres of light. Instead, they reveal that stellar existence can be remarkably dynamic and turbulent, influenced not just by mass and age, but also by rotational velocity. Rapidly rotating stars may also mix their internal layers more effectively than slower rotators, potentially prolonging their lifetimes compared to their more leisurely spinning siblings. When observed from tremendous distances, they might sparkle and shine like any other star in the night sky. Yet if you could somehow approach one closely, you would witness a wildly stretched sun, pulled and deformed by the relentless centrifugal forces of its own phenomenal speed. Hypergiants burning themselves. Away hypergiants represent some of the most unstable and short-lived stellar objects in the entire universe. Their absolutely immense size comes at a tremendous cost. They burn through their nuclear fuel so ferociously, so recklessly, that their outer layers simply cannot remain gravitationally bound to the core. Instead, these layers are shed into space through powerful stellar winds, with these stars losing more mass than our Sun's entire weight in just a few thousand years. Eta Carinae, perhaps the most famous hypergiant currently observable, sits surrounded by a vast, complex nebula created entirely from material it has violently blasted into the surrounding space during periodic eruptions. These massive storms of gas and dust enrich the entire galaxy with heavy elements that will eventually become incorporated into new stars, planets, and potentially even living organisms. But for the hypergiant star itself, this process represents nothing but pure destruction. Its ultimate fate is almost certainly to explode in an extraordinarily violent supernova, perhaps even leaving behind a black hole as its final legacy. These stars are essentially cosmic firestorms, beautiful and terrible in equal measure, showing us the absolute extremes of what a star can become before it tears itself apart. When stars encounter black holes, a star that ventures carelessly close to a supermassive black hole faces a truly violent end. The black hole's tidal forces, the differences in gravitational pull between the star's near side and far side, stretch it like cosmic taffy. If the star strays within what's called the tidal radius, it gets torn completely apart in a dramatic event astronomers call a tidal disruption event. The stellar material doesn't simply vanish. Instead, it spirals inward toward the black hole, forming an incredibly hot, glowing accretion disk as it falls inexorably toward oblivion. This catastrophic process releases an intense burst of radiation that can briefly outshine all the combined stars of an entire galaxy, creating a cosmic beacon visible across billions of light years. Sometimes, jets of material are launched outward at nearly the speed of light, broadcasting the star's destruction across the universe like a cosmic distress signal. These events are relatively rare, but they provide astronomers with an invaluable method for studying otherwise completely invisible black holes lurking in the centers of distant galaxies. Each tidal disruption event is a cosmic drama of immense proportions, a brilliant star utterly shredded by gravity's ultimate force. The brilliant flares of tidal destruction. When astronomers detect sudden, intense flares of light emanating from the centers of distant galaxies, they may be witnessing the real-time destruction of an unlucky star by a supermassive black hole. These tidal disruption events occur when a star wanders within the black hole's powerful gravitational grasp and gets stretched beyond all recognition. The star's material forms a superhot accretion disk, heating to temperatures of millions of degrees and shining brilliantly in X-rays and ultraviolet light. These spectacular flares can persist for months or even years as the black hole gradually devours its stellar meal, slowly dimming as the remnants of the unfortunate star finally disappear forever. Observing these events helps scientists measure the masses of supermassive black holes and develop better understanding of how galaxies evolve over cosmic time. They also serve as powerful, sobering reminders that even stars immense, radiant, and seemingly eternal are not safe from the deeper, more fundamental forces that shape the universe's architecture. To witness one of these events unfold through our telescopes is to glimpse the raw, consuming hunger of gravity in its most extreme form. Gravitational waves from colliding stellar corpses. When two neutron stars in a close binary system gradually spiral together over millions of years, their eventual collision becomes one of the most dramatic events the universe can produce. These mergers release tremendous energy, not only as light and gamma rays, but also as ripples in the very fabric of space-time itself, gravitational waves that Einstein predicted but never lived to see detected. These waves travel outward in all directions at the speed of light, literally stretching and squeezing space itself as they pass through it. In 2017, astronomers detected gravitational waves from precisely such a collision, followed almost immediately by bursts of gamma rays and then visible light. It marked the first time in human history that we observed both gravitational waves and electromagnetic radiation from the exact same cosmic event, opening an entirely new window on the universe. These neutron star collisions also forge extremely heavy elements like gold, platinum, and uranium, seeding the universe with rare materials that will later become incorporated into planets and eventually, perhaps, into jewelry worn by beings not yet born. Every ripple of gravitational waves we manage to detect represents a message from stellar remnants, colliding at unimaginable distances, carrying information about the most extreme physics in nature. Stars exiled to intergalactic darkness. Not every star remains safely within its home galaxy. Some get flung outward at such phenomenal speeds that they completely escape their galaxy's gravitational pull, drifting alone through the vast, empty darkness between galaxies. These rogue stars can be launched by violent events such as extremely close encounters with supermassive black holes or the chaotic breakup of dense star clusters. Once ejected, they wander the cosmic void indefinitely, carrying any surviving planets along with them into incomprehensible isolation. Imagine a lone sun billions of light years from its birthplace, traveling endlessly with absolutely no galaxy to call home, its light gradually dimming as it journeys through the emptiness between galactic islands. Though these intergalactic wanderers are incredibly difficult to detect against the darkness, astronomers believe countless such stars might be scattered throughout the universe like glowing embers blown from a dying fire. They remind us that space is not static, but constantly filled with motion and chance encounters, and that even something as massive and luminous as a star can be cast permanently adrift in the immense cosmic sea. The universe's first stellar giants. In the extremely early universe, before galaxies had taken recognizable shape, the very first generation of stars was born from pristine clouds of primordial hydrogen and helium. Astronomers call these mysterious objects population 3 stars, and they were likely absolutely enormous, some perhaps hundreds of times more massive than our Sun. With no heavy elements yet existing to help cool the gas clouds they formed from, these ancient giants grew rapidly and burned with absolutely ferocious intensity. Their lifespans may have lasted only a few million years, a brief cosmic flash compared to the billions of years typical stars enjoy. When these first stars died, they exploded in colossal supernovae that seeded the universe with the very first carbon, oxygen, iron, and other heavy elements, the fundamental building blocks necessary for planets and eventually life. None of these primordial stars survive today. They all burned out long ago in the universe's youth. But their fingerprints remain visible in the ancient chemical patterns astronomers can still detect in the oldest observable stars. By carefully studying those subtle clues, scientists slowly piece together the story of how the first light pierced the cosmic darkness, beginning the long transformation of the universe from a realm of pure hydrogen into a place capable of fostering complexity and life. The ultimate fate of sun-like stars. When stars similar to our Sun finally reach the end of their extraordinarily long lives, they shed their outer layers in beautiful, expanding shells and leave behind hot, dense cores called white dwarfs. Initially, these stellar remnants shine brilliantly, glowing intensely with the residual heat left over from their past nuclear fires. But over billions upon billions of years timescales that dwarf even the current age of the universe, they slowly radiate that energy away into space, gradually fading into darkness. The theoretical final stage is called a black dwarf, a cold, dead, stellar remnant that no longer emits any light whatsoever. None exist yet in our universe. The cosmos itself simply isn't old enough for even the most ancient white dwarfs to have cooled down that completely. The concept of black dwarfs belongs to the incomprehensibly distant future, an era when the universe will be a much quieter, much darker place. They represent the ultimate destiny, awaiting countless suns scattered throughout space, a silent testimony to the fact that even the most brilliantly radiant stars must eventually surrender to time's patient, unstoppable advance. The long darkness, awaiting the cosmos. If the universe continues expanding forever as current observations suggest, then its extremely distant future may be characterized by a long, slow descent into darkness. Stars will gradually exhaust all their nuclear fuel, and no new ones will ignite to replace them. Red dwarfs, the slowest and most efficient burners, could potentially glow for trillions of years. But even these patient suns will eventually fade completely. Galaxies will slowly grow dim as their stellar populations age and die. Planets will freeze solid in the cosmic cold. The night sky will gradually empty of starlight, leaving only darkness punctuated by occasional flashes from colliding stellar remnants. In this vision of the future, sometimes called the heat death of the universe, the cosmos becomes profoundly cold and utterly quiet, with only ancient black holes and the faint, cooling embers of dead stars remaining. Though this future lies unimaginably far away, so distant that the numbers involved become almost meaningless, the thought carries both sadness and strange peacefulness. The story of stars has both a beginning and an ending, and we are fortunate enough to be alive at a moment when the sky remains bright and filled with their light. To look upward now is to witness a universe still in its vibrant, star-filled youth. Could new stars shine in future universes? While our universe may one day fade into terminal darkness, some intriguing theories from modern cosmology suggest this might not represent the absolute end of the story. Certain speculative ideas propose that our cosmos might somehow bounce, or perhaps give rise to entirely new universes through processes we don't yet fully understand. In those fresh cosmic beginnings, the magnificent cycle of star formation could potentially ignite once more. The elements forged in our universe, all that carbon, oxygen, iron, and gold, created in stellar cores and supernovae, might seed the next universe, ensuring continuity across cosmic generations, stretching beyond imagination. Just as individual stars die but scatter the ingredients necessary for new stars to form, perhaps entire universes might undergo a similar rhythm, collapsing, rebirthing, and renewing in an eternal cycle. Though highly speculative and currently impossible to test, This concept offers a vision where starlight never truly ceases to exist. Instead, it shifts across scales larger than we can easily comprehend or imagine. In this view, the stars shining above us tonight are not merely part of our universe, but participants in a pattern that could potentially repeat endlessly, an eternal cosmic dance of light and renewal. The smallest stars burning for trillions of years. Not all stars live fast and die spectacularly young. The smallest ones, called red dwarfs, consume their nuclear fuel so incredibly slowly and efficiently that they can shine steadily for trillions of years, far, far longer than the current 13.8 billion year age of the entire universe. These stars appear dim and cool compared to our Sun, often remaining completely invisible to the naked eye from Earth despite their overwhelming abundance. Yet they represent by far the most common type of star in the cosmos, making up the vast majority of all suns in the Milky Way and presumably in other galaxies as well. Because they live such extraordinarily long lives, red dwarfs could potentially host planets where life has unimaginable amounts of time to emerge, evolve, adapt, and perhaps develop into forms we couldn't begin to imagine. None of these patient stars has yet reached old age since the universe itself remains far too young. That means the night sky of the incomprehensibly distant future will still be illuminated by these tiny, enduring embers long after brighter, more massive stars like our Sun have vanished completely. The fading twilight of the far future. As the cosmos ages over incomprehensible timescales, the brightest, most massive stars will naturally burn out first. Blue giants and hypergiants live only a few million years before exploding. Stars similar to our Sun last several billion years. But red dwarfs, those small, efficient stellar engines, can potentially endure for multiple trillions of years. Over these immense timescales extending far beyond human comprehension, red dwarfs will gradually become the dominant and eventually the only light sources remaining in the universe. The galaxies of that inconceivably distant future may glow only with their faint, ruddy light, creating a softer and lonelier sky than the one we know today. Eventually, even these longest-lived stars will finally exhaust their nuclear fuel, gently fading into white dwarfs, and ultimately, after timescales beyond calculation, into black dwarfs. The universe will shift from a bright, star-filled expanse to one illuminated only by fading embers, then finally to complete darkness. It's a vision of cosmic twilight where the last stars burn quietly, patiently, carrying the universe into its final chapters. For now, though, we live in astronomy's golden age, surrounded by brilliant suns of every size, color, and type. Stars dancing around supermassive black holes. At the centers of most large galaxies lurk supermassive black holes, monsters millions or even billions of times heavier than our Sun. Remarkably, stars can actually orbit extremely close to these gravitational behemoths, tracing paths that test the absolute limits of physics and gravitational theory. In our own Milky Way, astronomers have successfully observed individual stars racing around Sagittarius A*, the supermassive black hole sitting at our galactic core. One particularly well-studied star, designated S2, swings within just 17 light hours of the black hole during its closest approach, a cosmic hair's breadth in astronomical terms. At that point, it moves at more than 5,000 kilometers per second, roughly 2% of light speed. Observing these extraordinary orbits allows scientists to measure the black hole's mass with remarkable precision and to directly confirm Einstein's predictions about how extreme gravity warps the very fabric of space-time. These stars manage to survive in regions where we might reasonably expect them to be torn completely apart, demonstrating that even in the literal shadow of a supermassive black hole, the graceful dance of starlight can somehow endure. Hypervelocity stars escaping their galaxies. When a star strays dangerously close to a supermassive black hole, it doesn't always end in complete destruction. Sometimes, through complex gravitational interactions, the star gets flung away at truly tremendous speeds, accelerated by the black hole's immense gravity, like a stone from a cosmic slingshot. These so-called hypervelocity stars can travel at millions of kilometers per hour fast enough to completely escape their home galaxy's gravitational pull and continue traveling indefinitely into intergalactic space. The Milky Way contains several such runaway stars currently racing outward toward the void, their journeys likely having begun near Sagittarius A*, where close gravitational encounters with the central black hole acted as a natural accelerator for any planets that might orbit such a hypervelocity star. Assuming any survived the violent acceleration, the result would be truly extraordinary. An entire solar system cast permanently adrift, speeding alone through the cosmic darkness at incredible velocity, gradually leaving behind everything it once knew. The discovery of these stellar exiles reveals just how dynamic galaxies truly are and demonstrates how black holes shape not only what falls inward toward them, but also what gets hurled violently away. The hidden multiplicity of stars. To the unaided human eye, a star typically appears as a single point of light, piercing the darkness. But in reality, many, perhaps even most stars are actually doubles, triples, or even larger gravitationally bound groups orbiting common centers of mass. Binary star systems are especially common throughout the galaxy. Some pairs orbit so close together that they exchange matter between them, while others circle so far apart that they complete a single orbit only once every many thousands of years. For a hypothetical observer standing on a planet within such a system, the sky might feature 2 or 3 suns rising and setting in complex patterns, casting multiple overlapping shadows across the landscape. Famous examples include Alpha Centauri, our nearest stellar neighbor system, which actually contains 3 stars bound together in a gravitational dance. By carefully studying these pairs and groups, astronomers gain crucial insights into how stars originally form and subsequently evolve. What looks from Earth like a solitary point of light in the night sky is frequently a hidden family of suns orbiting together in long, graceful cosmic choreography. How stellar death triggers stellar birth. When a massive star concludes its life in a spectacular supernova explosion, it doesn't simply disappear from existence. Instead, it actively reshapes its entire surroundings. The explosion blasts powerful shock waves outward into nearby clouds of gas and dust, compressing them significantly and often triggering fresh waves of new star formation. In this beautiful way, the death of one star can directly trigger the birth of many others. Our own sun may well have been born from precisely such an event billions of years ago, its birth nebula enriched by heavy elements scattered by a previous generation of massive stars. These ongoing cycles ensure that galaxies remain perpetually fertile with starlight, continuously recycling matter into new forms and structures. Every brilliant star that dies leaves behind far more than ashes and darkness. It leaves the vital seeds of future suns, planets, moons, and perhaps eventually life itself. Stars don't simply end their stories and vanish. They pass the torch forward, igniting the next chapters in the ongoing, never-ending story of the cosmos. Rare, stars that explode multiple times. While most stars that explode as supernovae end with finality, a few remarkable exceptions defy our expectations. In extremely rare cases, a massive, unstable star may erupt violently, somehow survive that catastrophic blast, and then explode again years or even decades later. These unusual events are called pulsational pair instability supernovae. The star becomes profoundly unstable, ejects enormous amounts of mass in a violent eruption, then somehow stabilizes temporarily before eventually collapsing for good in a final explosion. Such stars shine unpredictably, producing multiple brilliant outbursts that can initially confuse astronomers into thinking they're witnessing repeated supernovae occurring in exactly the same location. These exotic stellar deaths highlight the extraordinary diversity in the fates awaiting massive stars and underscore how much astronomers still have to learn about the absolute limits of nuclear fusion and stellar instability. In cosmic terms, They represent stars that seem almost unwilling to let go quietly, leaving behind a dramatic, flickering record of their prolonged struggle against gravity's final, inevitable pull. Type Ia supernovae. As cosmic measuring sticks, type Ia supernovae represent a special category of exploding stars that shine with remarkable consistency. They occur when a white dwarf star in a binary system gradually accumulates too much matter stolen from its companion star, eventually triggering a catastrophic runaway thermonuclear explosion. Because these explosions always occur at roughly the same critical mass threshold, their peak brightness remains nearly uniform, regardless of location in the universe. This makes them what astronomers call standard candles, reliable cosmic beacons that can be used to measure enormous distances across space. By carefully comparing how bright these supernovae appear from Earth to how bright they truly are intrinsically, scientists can precisely calculate how far away they must be. Type ER supernovae played an absolutely pivotal role in one of astronomy's greatest discoveries, the accelerating expansion of the universe driven by mysterious dark energy. They are not only spectacular stellar deaths, but also fundamental measuring tools that help humanity grasp the true immensity of the cosmos itself. Supernovae enriching the galactic ecosystem. Every single atom of gold, silver, iron, calcium, and countless other heavy elements found on Earth was originally forged in the nuclear furnace at the heart of a long-dead star. When massive stars explode as supernovae, they blast those precious heavy elements violently into space, dramatically enriching the interstellar medium throughout their region of the galaxy. Over vast stretches of time, that enriched material gradually mixes with other gas and dust, eventually becoming incorporated into new generations of stars, planets, asteroids, and comets. Without supernovae continuously seeding space with heavy elements, the universe would be an incomparably simpler place, filled almost exclusively with hydrogen and helium. Instead, every supernova explosion literally sows the seeds of future complexity. The iron flowing through your blood and the calcium forming your bones were once carried outward in precisely such a cataclysmic blast, drifting through interstellar space for millions or billions of years before eventually finding their way into the molecular cloud that would birth our solar system. Supernovae are simultaneously violent endings and beautiful beginnings, scattering the ingredients necessary for life far and wide across the cosmos. You are literally made of stardust. It may sound like poetic exaggeration, but it represents literal scientific truth. The atoms forming your body were genuinely forged inside stars. The oxygen you breathe with every breath, the carbon atoms forming the backbone of every cell, the iron dissolved in your blood, all were created through nuclear fusion in stellar cores and supernova explosions. Billions of years ago, long before Earth even existed as a world, those specific elements were drifting freely through interstellar space, patiently awaiting their chance to come together into something new. Carl Sagan famously observed, "We are made of star stuff," and that poetic phrase captures a profound reality about existence itself. Every human being, every tree, every stone, every living creature is essentially a collection of recycled stardust, assembled into new forms. When you gaze upward at the distant stars scattered across the night sky, you're not just looking at beautiful but alien objects. You're seeing your own ultimate origins written in light. The stars gave us these raw materials through their lives and deaths, and in turn, we represent the universe itself becoming aware of its own existence. The connection between humanity and the stars is direct, literal, and deeply humbling. Iron. The element that signals a star's doom. Stars shine brilliantly because of nuclear fusion, the process of combining lighter elements into heavier ones, releasing tremendous energy with each reaction. However, this process works efficiently only up to a certain point. When a star's core begins fusing silicon atoms into iron, the fundamental balance suddenly changes forever. Iron represents a unique turning point because it does not release energy when fused into heavier elements. Instead, Fusing iron actually absorbs energy rather than producing it. This means that once iron begins accumulating in significant quantities in a star's core, fusion can no longer provide the outward pressure necessary to support the star against its own crushing gravity. At that critical moment, catastrophic collapse becomes absolutely inevitable, usually leading to a supernova explosion. The presence of iron essentially represents a death sentence for massive stars, marking the precise moment when their fuel supply runs out in a fundamental, irreversible way. It's remarkable to consider that this ordinary metal, so familiar and common here on Earth, also serves as the cosmic tipping point that determines exactly when stellar giants will finally fall into darkness. The delicate balance keeping stars stable. A star maintains its existence through a remarkably delicate balance between two opposing fundamental forces. Gravity constantly pulls all the star's mass inward, trying relentlessly to collapse it into an ever denser core. Nuclear fusion in the center pushes outward with tremendous heat and radiation pressure, counteracting gravity's inward squeeze. As long as these two forces remain approximately equal, the star achieves hydrostatic equilibrium and shines steadily. Too much fusion pressure causes the star to swell. Too little allows it to contract. Our Sun has successfully maintained this precise balancing act for roughly 4.6 billion years, and will continue doing so for approximately 5 billion more years. But when the hydrogen fuel at the star's center eventually runs out completely, that delicate balance will tip irreversibly, and the Sun will begin transforming into something entirely new and different. This ongoing tug of war between gravity and fusion represents the fundamental reason stars exist as steady, reliable sources of light, rather than either collapsing instantly into dense remnants or blowing themselves violently apart. The speed at which different stars consume their fuel. Not all stars approach life with the same patience. The most massive ones consume their nuclear fuel at truly astonishing rates, up to 1 million times faster than our Sun burns its hydrogen. This means that although these giants are much larger and incomparably more powerful, they live incredibly brief lives, sometimes lasting only a few million years before exhausting their fuel completely. By comparison, our Sun will shine steadily for roughly 10 billion years, total 1,000 times longer. These fast-burning giants blaze intensely with blue-white light, pouring tremendous energy into surrounding space and significantly shaping their host galaxies with powerful radiation and stellar winds. Their brief but spectacular lives inevitably end violently, often in supernova explosions that seed the cosmos with freshly forged heavy elements. The stark contrast between these stellar giants and patient stars like our Sun clearly demonstrates how mass dictates ultimate destiny in the stellar world. The bigger and more massive the star, the shorter and more dramatic its life becomes. They resemble cosmic fireworks, absolutely dazzling but heartbreakingly fleeting, while smaller stars remain as steady candles burning across deep time, patient witnesses to cosmic history, the Sun's inevitable transformation. Our own Sun, though remarkably stable now, faces a dramatic future transformation. In approximately 5 billion years, it will finally exhaust the hydrogen fuel in its core. As fusion shifts to burning helium in a shell surrounding the core, the delicate balance inside will fundamentally change, and the Sun will begin swelling enormously into what astronomers call a red giant. Its outer surface will expand outward dramatically, quite likely engulfing the inner planets Mercury and Venus, and possibly even reaching Earth's current orbit. The Sun's outer atmosphere will glow a dim, deep red, far cooler than today's familiar golden yellow light, while the exposed core contracts and heats to extreme temperatures. Eventually, the Sun's outer layers will drift gently away into surrounding space, forming a beautiful glowing planetary nebula, while the remaining core shrinks into a white dwarf that will slowly cool over trillions of years. Though this transformation lies in the incomprehensibly distant future, it serves as a sobering reminder that even stars as stable and reliable as our Sun are ultimately temporary, Following paths written into the fundamental physics of fusion and gravity, our familiar star will one day become something entirely different, beautiful in its own way, but no longer the sun we know, the brilliant dog star dominating Earth's sky. On any clear winter night, the star Sirius dominates the heavens with unmistakable brilliance. Also called the dog star because of its position in the constellation Canis Major, it shines nearly twice as brightly as the next brightest star visible from Earth Canopus. Part of Sirius's impressive brilliance comes from its genuine intrinsic luminosity. It truly is a bright star, but its relative closeness to Earth, only about 8.6 light-years away, significantly contributes to making it appear so dazzling in our sky. Ancient cultures around the world noticed and revered Sirius for thousands of years, linking it intimately with mythology, agricultural calendars, and navigation. In ancient Egypt, the heliacal rising of Sirius in the dawn sky reliably heralded the annual flooding of the Nile River, making it crucially important to Egyptian civilization. Today, astronomers understand that Sirius is actually a binary system consisting of Sirius A, a brilliant hot white star, and Sirius B, a faint but incredibly dense white dwarf that was once a massive star itself. To the naked eye observing from Earth, these two stars blend seamlessly into one intensely bright point of light. Sirius serves not only as the sky's brightest stellar beacon, but also as a reminder that appearances often hide deeper, more complex stories. Ancient names, connecting us across millennia. Long before the invention of telescopes revolutionized astronomy, people across countless cultures gave meaningful names to the brightest stars they could observe. These names carried deep significance, often tied to agriculture, navigation, mythology, or seasonal changes crucial to survival. Stars like Betelgeuse, Rigel, and Aldebaran trace their names to Arabic astronomical traditions, while Vega and Altair derive from ancient Arabic and Latin roots. In China, India, Greece, Egypt, and countless other civilizations, stars were woven intricately into stories and systems that helped people make sense of the heavens above them. Even today, those ancient names endure across cultures and languages, creating a direct connection between modern humans and people who gazed at precisely the same sky many thousands of years ago. While contemporary astronomers often use systematic catalogue numbers for precision and clarity, the old traditional names remain in common use, echoing across vast stretches of time. They remind us that humanity's bond with the stars extends far beyond pure science. It's deeply cultural and spiritual, stretching back to the very beginning of human civilization, when our ancestors first looked upward and wondered about those mysterious points of light. When humans navigated by starlight alone, before the invention of magnetic compasses, GPS satellites, and electronic navigation, the stars served as humanity's most reliable guides across unknown territories. Polynesian voyagers successfully crossed thousands of kilometers of open Pacific Ocean by memorizing the precise rising and setting points of specific stars, steering their outrigger canoes with remarkable accuracy. The North Star, Polaris, appearing almost fixed in position in the northern sky, has been used for countless centuries in the northern hemisphere to determine latitude and maintain directional heading. Arab traders, Greek sailors, and Viking explorers all relied fundamentally on detailed knowledge of the sky to guide their journeys across seas and deserts. Even the seasonal migrations of peoples and animal species were often carefully timed by stellar positions and the appearance of specific constellations. These essential skills were transmitted orally across generations, with songs, stories, and mnemonic devices encoding entire detailed star charts in human memory. Celestial navigation required extraordinary memory and keen observational skill, but it worked reliably for millennia. Long before modern technology, humans placed complete trust in starlight to carry them safely to distant lands. Today, those same stars continue shining above us, though we now look to them more with wonder than necessity. The slowly changing pole star. Polaris currently enjoys fame as the North Star, serving as the one apparently fixed point in the sky, while all other stars appear to rotate around it throughout the night. But it hasn't always held this special role, and it won't maintain it forever. Earth's rotational axis slowly wobbles in a long cycle lasting approximately 26,000 years, a motion astronomers call axial precession. This gradual wobble means the point in the sky toward which Earth's north pole aims shifts continuously, though imperceptibly slowly from a human perspective. Around 3000 BCE, the star Thuban in the constellation Draco marked true north for ancient civilizations. In approximately 12,000 years from now, the brilliant star Vega will assume the role of pole star. Polaris simply represents the current chapter in a very long story of shifting celestial markers. Ancient monuments like certain pyramids and megalithic stone circles were carefully aligned to different stars that once held the northern crown. Watching the pole star change over millennia is like watching Earth itself breathe across enormous timescales, a powerful reminder that even the patterns we trust most in the heavens are always gradually moving and evolving. Our SKY looks different from other worlds. If you could somehow stand on a distant planet, orbiting a star dozens of light years away, the familiar constellations you know from Earth would completely vanish. Stars appear grouped together from our specific vantage point only because of perspective and relative distance. Viewed from a completely different location in the galaxy, those carefully imagined shapes and patterns would warp beyond all recognition into entirely unfamiliar arrangements. On a planet orbiting Proxima Centauri, our own sun would appear as just a faint additional star somewhere in the sky, unremarkable among thousands of others. From the Andromeda Galaxy, the entire Milky Way would appear as a glowing band of light, while the individual stars we hold so familiar would be utterly lost in the combined brilliance. This shifting of perspective demonstrates clearly that constellations are illusions created by distance and viewing angle. The night sky is not a fixed picture painted on a dome above us, but rather a three-dimensional ocean of suns that appears differently from every possible shore. To imagine other skies is to realize how profoundly our view of the universe gets shaped by where we happen to stand within it. Future civilizations will draw new star maps. The constellations we recognize today, Orion the Hunter, Cassiopeia, the Big Dipper, and all the others are fundamentally temporary patterns. Over thousands and millions of years, stars drift through space relative to one another, following their own individual paths through the galaxy. Very slowly but inexorably, the familiar patterns we've known throughout human history will warp beyond recognition. In about 50,000 years, Orion will have lost his distinctive belt as those stars drift apart. In just a few million years, the Big Dipper will no longer resemble any kind of dipper at all. To us, these changes occur far too slowly to notice within a human lifetime, but on cosmic timescales, the sky itself continuously transforms and evolves. Future civilizations, whether human descendants or entirely different species, will inherit night skies filled with completely different patterns and will create their own unique mythology tied to their particular era. The constellations we see tonight represent snapshots of a fleeting arrangement, temporary configurations that will eventually become as outdated as ancient maps of imagined seas and mythical lands. They remind us that nothing in the cosmos remains permanent, not even the patterns we draw among the stars. Stars gradually drift across the heavens. Though stars appear fixed and unchanging from our limited perspective, they're actually in constant motion through space. Their immense distances from Earth make this movement nearly invisible to casual observation, but over centuries and millennia, the subtle changes accumulate into noticeable shifts. This gradual stellar drift is technically called proper motion. Barnard's star, for example, displays noticeably different position against the background sky every few decades, exhibiting the fastest proper motion of any star visible from Earth. Ancient detailed star maps, when carefully compared to modern observations, clearly reveal this slow shuffle of the heavens. Even the shapes of familiar constellations change subtly over recorded human history. This continuous shifting reminds us that what appears eternal and unchanging is actually temporary and fluid. The stars are not painted dots on some distant dome surrounding us. They're independent suns, each traveling through the galaxy along its own unique path, telling its own story. Their light traces gradual lines of motion across cosmic time, forever rearranging the stellar landscape even if human eyes typically cannot perceive the change happening. The sun's changing stellar neighborhood, our sun doesn't remain in a fixed position either. It orbits the center of the Milky Way once every 220 to 250 million years or so, completing what astronomers call a galactic year. Along this immense journey, the sun's immediate neighborhood continuously changes as different stars drift past. Stars that are relatively near us today will eventually drift away to other parts of the galaxy, replaced by entirely different stellar neighbors crossing our galactic path. In Earth's distant past, the sun's closest stellar companions were completely different from those we observe today. Their combined light contributed to skies that would have looked subtly different from our current heavens. As the sun continues its grand orbit, the constellations surrounding us will slowly but inevitably transform, and the stars we consider familiar will fade from view, replaced by others emerging from different directions. This cosmic motion reveals that even our sun's place in the galaxy is temporary and transitional, merely one part of a magnificent rotation carrying us around the galactic center. To contemplate the night sky is to see just one frame of an endless journey where our stellar companions come and go across the vast ages. Globular clusters, ancient stellar time. Capsule's globular clusters rank among the most spectacular sights in astronomy. Dense, spherical swarms of stars, often containing hundreds of thousands of individual suns packed into a relatively compact space. They orbit around the outskirts of galaxies like glittering satellites, each one essentially a fossil preserved from the early universe. Many of the Milky Way's globular clusters are more than 12 billion years old, making them nearly as ancient as the universe itself, older than our sun, older than Earth, older than life. Their stars tend to be small, faint red dwarfs and long-lived giants, since any massive stars they once contained burned out eons ago. Viewed through a telescope, a globular cluster resembles a dazzling snowball of light, with stars crowding so tightly toward the center that they blur together into a continuous glow. These clusters represent far more than beautiful, astronomical objects. They serve as windows into cosmic history, showing us how the very first stars formed and evolved in the infant universe. Studying them is like reading an ancient history book written in starlight, tracing the early days of galaxy formation. Ancient stars nearly as old as time. Hidden among the younger stellar generations populating our galaxy are a precious few elders, ancient suns that date back almost to the dawn of cosmic time itself. Some metal-poor stars in the Milky Way are more than 13 billion years old, formed when the universe was less than 1 billion years old and still in its infancy. These remarkably old stars formed from primordial gas containing very few heavy elements because supernovae had not yet had sufficient time to significantly enrich the interstellar medium. Astronomers identify them by carefully studying their spectra, looking for chemical signatures that remain almost untouched since shortly after the Big Bang. Such ancient stars are extremely rare, but they offer invaluable clues about the very first moments of star formation, long before galaxies had matured into their current forms and heavy elements had filled space. To observe one of these stellar elders is to peer across nearly the entire age of the universe, connecting directly with a survivor from an era when the cosmos was still young, dark, and just beginning to sparkle with the first generation of starlight. Stars outliving the galaxies that formed them, galaxies themselves, are remarkably dynamic structures, sometimes colliding, merging with one another, or even being gravitationally torn apart by larger neighbors. Yet remarkably, individual stars within them can outlast these tremendous cosmic transformations. A star born in a small dwarf galaxy might find itself swept into a much larger galaxy after a collision and merger, yet continue shining steadily for billions of years despite its changed circumstances. Some stars may even get flung completely into intergalactic space, wandering alone long after their home galaxy has been disrupted or absorbed into something larger. In this way, stars can genuinely survive events that effectively erase the very structures that originally created them. It's a humbling reminder that while stars are products and inhabitants of galaxies, they're also independent entities capable of enduring dramatic changes in their cosmic environment. These lone survivors serve as witnesses to upheavals on almost incomprehensibly vast scales, carrying on faithfully long after galactic boundaries have shifted or vanished. Their light outlasts the cradles that first ignited them, continuing to shine across the endless darkness. Thank you so much for joining me on this gentle journey through the realm of stars tonight. We've traveled together from their fiery births in vast molecular clouds, through their long and steady lives of nuclear fusion, to their peaceful endings as fading embers, or their spectacular deaths in explosive supernovae. Along the way, we've discovered profound reminders that stars represent far more than distant points of light decorating the darkness. They're the architects and builders of everything we know, the creators of atoms, the keepers of cosmic time, the storytellers of the universe itself. It's deeply humbling to truly consider that the blood flowing through your veins, the air filling your lungs with each breath, the bones supporting your body, all were forged inside the hearts of ancient suns that lived and died billions of years ago. Stars existed, blazed brilliantly, and scattered their ashes so that you could one day exist here, breathing quietly beneath their eternal glow. Every night, sky isn't just a beautiful display to admire. It's a living history of creation itself, written across space in light that has traveled for countless years to reach your eyes this evening. As we close this story, you don't need to hold on to any specific details or facts. Let them drift gently away if they wish, like stardust dispersing on a cosmic breeze. What truly matters is the feeling, that profound sense of calm vastness, that peaceful recognition of being small but deeply connected to everything around you. You are genuinely part of this universe, woven from exactly the same fundamental fabric as the stars themselves. This isn't poetry or metaphor, it's literal truth. If you found comfort and peace here tonight, I would be deeply grateful if you considered leaving a like or subscribing to this small channel, or perhaps sharing a thought down in the comments section. It genuinely helps other dreamers discover this space, one peaceful soul at a time. But truly, there's nothing more you need to do right now, nothing requiring your attention or action. Just allow your breathing to slow naturally, becoming deeper and more rhythmic. Let your body soften and release any remaining tension. Feel the accumulated weight of the day gently slipping away from your shoulders. The stars will continue burning faithfully through the night. The galaxies will continue their ancient rotation, and you can simply rest now, peacefully and completely. Somewhere out there in the vastness of space, a star is shining whose light won't reach Earth for thousands of years yet. By the time that ancient light finally arrives here, you will have dreamed countless dreams, and this world will have turned through countless dawns. The stars remind us that time is truly vast, deep and patient and gentle, a natural current we can trust ourselves to surrender to completely. So, let yourself drift now, carried peacefully by that eternal current into the quiet darkness where rest awaits. Sleep peacefully, dear traveler. Dream deeply, and always remember that the same starlight filling the infinite sky has always been within you, waiting. Good night.